So it has taken us a few days to finally get there, but I think we finally solved the freeze effect problem inside Max. So looking at our proposal, it was the fourth and final of the four effects that we need to create, which is this freezed voice with the ability to stack pictures on top of each other. Kind of similar to what it's a mixture between what we did in the delay and the time stretch, where we have a buffer, essentially a buffer of data that we go in and read a certain value from. And rather than having a buffer that we have a really, really short loop on, there's a fantastic article from, where about is it here? So it's Jean-Francis Charles, I think is how you pronounce it, has this amazing academic article on sound processing using Max, where he does a lot of work with FFT and matrix processing inside of that sort of spectral sound space. And out of that came the amazing tools that you can find on the Cycling Sound 4 forum under Charles' spectral tutorials. And he has a bunch of examples that you can load up and use. Some of them don't work in latest versions, but if you're crafty enough, you can probably go about recreating them. So from about 4 onwards, they have the full patches that still work, but a lot of the earlier ones seem to have been misnamed or incorrectly positioned. I am using Windows. There is a Max version as well, so they might be slightly better. But the idea is that he has the bare bones of what we need to be able to create a freeze in a less robotic way, and it's laid out so nicely that we can use it to build what we need. So to give you an example of what we've got, I've got a bare bones Max patch here that is referencing the solo freeze FFT object that he creates for his basic freeze. And if we have a look at it, we can have a quick look through at what it actually is doing. So at the top, we've got some general, let me just delete that so we can see. We've got our FFT in, we've got a normal signal coming in from the Max patcher, and we've got a cartopole, so we're taking our normal Cartesian coordinates and turning them into the circular polar coordinates. If you think of, we are sending in audio data as a checkerboard, like a chessboard matrix, we need to turn them into a circular one. We are then doing some special sampling on the what I think is the amplitude, or the phase, sorry, so the time of that signal that we're bringing in, and we're wrapping it into the phase. So this should, if I bring up the reference, yes, so we're wrapping it between pi and minus pi. So whatever's coming in, if say it was a sloping line, it would then start to look more like a sine graph, because it's wrapped between certain values, so that it stays within the bounds of that circular polar coordinate. Then we have a special object called a catch, and then something you might be a bit more familiar with, a JIT.matrix. So a matrix is somewhere that we can literally just store numbers. If you're familiar with programming, it's kind of like an array, and we're going to make a special, really small array that's only got 2 planes over an arbitrary amount of dimensions. And if that sounds like gibberish, what we're doing is this signal that's coming in from the Max patch is a trigger, and that trigger tells the JIT.catch object to catch 2 channels worth of data into this matrix, and that will keep catching until this matrix is full. And the length, or the size of that matrix, is decided by this, which is the FFT info. So this is constantly polling the information coming in, or the audio coming in, and it's determining this object we've got coming out is the spectral frame size. So essentially what we're doing is we're setting the JIT.catch's frame size, so how much of a frame it catches is to 1 sample, if you will, inside the FFT. And the JIT.matrix total amount of dimensions is set to the same thing. So this is going to be something like 1024 if not even less. So it's going to be a really, really small chunk of audio, and it's going to be the equivalent to one sample in a spectral field. So it's going to be a really, really short sample of audio is loaded into this matrix. These numbers at the end are completely arbitrary, because that 2048 is just something we initialize it at, but we actually set it every single time that the FFT gets new information in. And then we now have a matrix established that stores all our audio data. What we need to do is just go into that matrix using jit.peak, and then output it as normal Cartesian coordinates again. So the layman's terms of what we're doing is we've got a button that captures one spectrum's worth of information, and then goes back in and repeats it back out. So to infinity. So this will be a non, what's the audio word we're looking for? A non-diminishing replay of the same sample over and over and over again, because it's not sampling from live anymore. What we need to do is find a way to recreate this so that it allows us to A, clear the matrix when it's we want a new sample, and B, store multiple samples. So we have a few options on how we're going to do it, but let's get started. So first thing I'm going to do is delete this. I'm going to bring in some audio. I'm going to do my easy DAC, my usual gain. Quick test.